the previous lesson, we found or we learned how to get the antiderivative of a radical function like the square root of x plus 4 with respect to x. But how do we find the antiderivative of a radical function, suppose the square root of x plus 4 being multiplied by another polynomial expression? Do we use the same process? Do we apply the substitution method? The answer to that is yes, we use the substitution method, but the process is not entirely the same. So, suppose we are asked to evaluate the antiderivative of 2x times the square root of x plus 4 with respect to x. So, what we need to do is to represent or to substitute a variable for our radicand. So, let's use the letter y or v. Let v be equal to our radicand, which is x plus 4. Okay? Then we get its derivative. What is the derivative of v? So it will be represented by dv. And then we get the derivative of x plus 4. The derivative of x is 1. So we will get 1 dx. But since it is 1, we can already remove 1 and simply write dx. So we'll have dv is equal to dx. And because we have already represented v as our x plus 4, we can now write 2x times the square root of v dv. How did we do it? Because v is equal to x plus 4, our expression, the square root of x plus 4, will become the square root of v. And since dv is equal to dx, we will simply write dv instead of dx. We can automatically substitute dx by dv. We are no longer going to divide dv and dx by a certain number because dx has no numerical coefficient other than 1. Alright. But since our expression is given by the antiderivative of 2x times the square root of v with respect to v, we notice something, that there is another variable instead of v. Because our intention is to make use of one variable as our representation. But since we have x here, we need to write x in terms of v. How do we do that? We will go back to our first representation, which is v is equal to x plus 4. We need to find the value of x in terms of v. So, to do that, we need to remove all other expressions beside x and move that to the other side, divide if necessary. So we will get v minus 4 is equal to x because we are going to move positive 4 to the left side of the equation. We will have v minus 4, and what will remain on the right side will be x. So v minus 4 is equal to x, meaning to say what we have here is v minus 4 instead of writing x. So we will get 2 times v minus 4 times the square root of v dv. This time, we already have one single variable. Okay, so before we proceed to anti-differentiation, we need to simplify first 2 and then v minus 4 and then the square root of v. We will multiply or distribute 2 to v minus 4 and get 2v minus 8 times the square root of v dv. But before we continue finding the antiderivative of this expression, we need first to simplify things out. So we can write v as v raised to 1/2. Therefore, we will get 2v minus 8 times v raised to 1/2 derivative of v. So that we can distribute v raised to 1/2 to 2v and negative 8. Alright. So, we will get 2v times v raised to 1/2 will give us 2 times v. The exponent of v is 1. And the exponent of the v outside the parenthesis is 1/2. If we multiply two variables, we are just going to add their exponents. So, we will get 1 plus 1/2. And we all know that 1 plus 1/2 is 3/2. So, we continue. We have negative 8, and then we multiply that to v raised to 1/2. This will give us 8v raised to 1/2. And then we copy dv. Again, how do we find 2v raised to 3/2 minus 8v raised to 1/2? We are going to distribute v raised to 1/2 to 2v minus 8. And that is 2v times v raised to 1/2. Again, we add the exponents if we multiply two variables. So, copy 2, then v raised to 1, v raised to 1/2. That would become v raised to 1 plus 1/2. That will give us 3/2 minus 8 times v raised to 1/2. Now, we can now, in here, we can now find the antiderivative of these two expressions. So, we will get 2 times v raised to 3/2 plus 1 over 3/2 plus 1, and then 8v raised to 1/2 minus 8 times v raised to 1/2 plus 1 over 1/2 plus 1 plus c. Okay. And then we simplify 3/2 plus 1. We will get 2 times v raised to 5 over 2 over 5 over 2 minus 8 times v, and then the exponent is 1/2 plus 1. We will have v raised to 3/2 over 3/2 plus c. Again, we are given a complex fraction, which is v raised to 5 over 2 over 5/2. And then, on the right side, we have v raised to 3/2 over 3/2. In this case, we again have to find the reciprocal of the denominator and get 2 over 5. So, 2 over 5 must be multiplied to 2v raised to 5/2. We will get 2 times 2 over 5 v raised to 5/2. 2 is the original numerical coefficient. Then we multiply it by the reciprocal of 5 over 2. We will get 2 times 2 over 5. Copy v raised to 5/2. We will do the same on the right side. We will get 8 times the reciprocal of 3 over 2. That is 2/3. And then copy v raised to 3/2. And then plus c. Okay. 2 times 2 over 5 will give us 4 over 5. Because we are going to multiply the integer to the numerator and copy the denominator. 4 over 5, v raised to 5 over 2 minus, we also have here 8 times 2/3. That would mean that we need to multiply 8 to the numerator, which is 2. We will get 16 over 3 v raised to 3/2 plus c. Now we are almost done because we are done simplifying, applying the anti-differentiation rules. We are now just going to resubstitute the value of v in this particular expression so that we can find our final answer. So, we are going to substitute x plus 4 to v. That will now give us 4 over 5, and then times the quantity of x plus 4 raised to 5 over 2. Again, we have 4 over 5 times, instead of writing v, we have x plus 4 raised to 5/2 minus 16 over 3. And instead of writing v, we have x plus 4 raised to 3/2 plus c. And so the final answer is this. This is now the antiderivative of 2x times the quantity of x plus 4 with respect to x. So I hope you are able to follow in finding the antiderivative of a radical times a polynomial.